Hey guys, welcome back. Today we're going to talk about, we're going to continue to talk about properties of exponents. So today we're going to learn about properties that involve quotients or division. So if I look at the first example, we've got 4 to the 5th divided by 4 cubed. Okay, so I'm going to do it a little bigger right here. If I had 4 to the 5th, 4 to the 5th is equal to 4 times 4 times 4 times 4 times 4 divided by 4 to the 3rd. Okay, so if you notice, if we could cancel these out, those two 4's would cancel out because 4 divided by 4 is 1. So we can cancel those two out, and we're left with, in the numerator, 4 to the 2nd power, which is 16. Okay, so in this case, if you look at this, it would be 4 to the 5th divided by 4 to the 3rd would be 4 squared. And that's because to divide powers with the same base, we actually subtract the exponents. All right, so if you notice, we just took 5 minus 3, and we got 2. Okay, if we used variables and we had the same base, and again, this is crucial, you have to have the same base, okay, a to the m divided by a to the n would be a to the m minus n. Okay, so looking at the examples we have down here, if we had 2 to the 10th power divided by 2 to the 4th power, 10 minus 4 is 2 to the 6th power, and 2 to the 6th power is actually 64. Okay, if we had negative 3, notice it's in parentheses. If we take 7 and we subtract 3, we're going to get negative 3 to the 4th power, and that's going to be equal to 81. Okay, now number 3, we're actually going to multiply the 2 together on the numerator first, and our rule of multiplication says that 5 to the 4th times 5 squared, we have the same base, so we're just going to add the exponents. 5 to the 6th divided by 5 to the 3rd is going to give us 5 to the 6 minus 3 is 3, and that gives us 125. Okay, if I had a fraction and I multiplied by x to the 6th power, I'm actually going to put this over 1. And with fractions, you go straight across. So if we lined it up, 1 over x to the 4th times x to the 6th over 1, and we went straight across, we would get x to the 6th divided by x to the 4th. Now we're dividing. We have the same base, so 6 minus 4 is 2, and we would end up with an answer of x squared, or x to the 2nd. 6 to the 11 divided by 6 to the 9th would be 6 squared, which would be 36. Okay, negative 4 to the 9th divided by negative 4 to the 7th, we have the same base of negative 4, would be negative 4 squared, which would be equal to 16. Okay, number 7, we're going to multiply across, so 9 to the 5th times 9 to the 3rd would be 9 to the 8th. Divided by 9 to the 6th, now we're subtracting, and we get 9 squared, which is 81. Okay, here's another fraction one. So again, I'm just going to put this over 1, go straight across. I'm going to get y to the 8th divided by y to the 5th. 8 minus 5 is 3, so we end up with y to the 3rd, or y cubed. Okay, now when I have a number, a coefficient here, 2x to the 5th, it's just like dividing, but we don't have, our coefficient for the denominator is actually 1. So 2 divided by 1 is 2, and x to the 5th divided by x to the 3rd is just x to the 2nd. Okay. All right, so power of a quotient property, another one. So if we had this example, 2 to the 5th cubed, it's just like saying 2 to the 5th times 2 to the 5th times 2 to the 5th, okay, which is equivalent to, if we took 2 times 2 times 2, which would be 2 to the 3rd power divided by 5 to the 3rd power, 5 cubed. So we would just simplify, and because they're just numbers, we can end up with 8 divided by 125, okay. But, so looking at the example, you take the numerator and you actually just raise it to the 3rd power, and then you do the same thing with the denominator, so don't forget to do both. Okay, so they would both be to the 3rd power. So to find a power of a quotient, we just find the power of each number, or numerator and denominator. So if these were variables, it would be a to the m power divided by b to the m power. Okay, so looking at our examples here, the first example that we have, we've got 3 squared and we're cubing it, so that's going to be equivalent to 3 to the third power divided by 2 to the third power, which would be 27 over 8. Okay, number 2 is variables, but your x would be cubed and your denominator, your y, would be cubed, and you would be finished. Okay, number 3. Okay, number 3, be careful because it's a negative, all right? With a negative, you've got to pick either the numerator or denominator to assign the negative to, because it's inside the parentheses. So we're going to take the -7 and we're going to square it, and then it's going to be divided by x squared. Okay, and we don't want to do it to both because a negative divided by a negative would be a positive, and this is a negative. So -7 squared would be 49, and then x squared would be x squared. Okay, number 4, if we had our numerator is a, it would be a to the 4th divided by b to the 4th. Okay, and we do it until we simplify as much as we can. We can't do anything there. Okay, number 5, here's a negative, so we're going to take -5 and we're going to cube it, divided by y cubed, and evaluate that exponent. We're going to end up with -125 divided by y cubed as our final answer. All right, number 6 gets a little more complicated, okay, because now we're taking a power and we're raising it to a power. So we're going to use the rule of power to a power. We multiply, so we end up with x to the 4th, okay, and then our 4 is actually going to be squared, okay, and our y is squared because they're on the outside of the parentheses here. So we end up with x to the 4th divided by 4 squared is 16, y squared. So that would be our final answer. Okay, number 7, we're going to take the 5, we're going to cube it, and then we're going to take the x, and x squared cubed would be x to the 6th, divided by 5 cubed, and then we'd have y to the 3rd. Well, we can actually cancel out right here. We could evaluate 5 cubed is 125, but either way, we can cancel out right there, and our answer is x to the 6th divided by y to the 3rd. Okay, number 8, we would get a to the 2nd, and then we took it to the 5th, it would be a to the 10th power divided by b to the 5th times 1 over 2a squared. Okay, now we're going to go straight across. So when we do that and multiply, because we're multiplying fractions, we're going to get a to the 10th divided by 2, okay, and it's going to be a squared and then b to the 5th. Okay, I like to put my variables in alphabetical order. All right, makes it easier to simplify. So now we've got 2a variables, so we're going to have to simplify this. A to the 10th divided by a squared, we're going to end up with a to the 8th, okay, divided by 2. Now the a squared had canceled out, so we're left with 2b to the 5th. Okay, so that would be our answer there. So think about it. If you had a to the 10th, you'd have 10 a's divided by 2 a's here, so you would have 8 left. Number 9, we're going to end up with 2 to the 5th, s to the 5th, divided by 3 to the 5th, t to the 5th, and we're multiplying that by t divided by 16. Okay, so now we're going to go straight across. Well, we'll evaluate. We've got 2 to the 5th is 32, and then we have s to the 5th, t, divided by 3 to the 5th is, okay, 243. So we've got 243, all right, and that's an s there, 243 t to the 5th times 16. Okay, so now actually looking at this, we can actually simplify 32 and 16. 32 divided by 16 is just 2. Okay, so we're left with 2s to the 5th t divided by 243 t to the 5th. And one more step, we've got t to the 1st divided by t to the 5th, okay, would be t to the -4, which means that would end up as the denominator, 2s to the 3rd over 243 t to the 4th. Okay, that one was a little bit more complicated. Okay, so now I want you to go on and go through the practice problems that we have on the back and then compare them to the key. Thank you.